Dr. Curt Rom is professor in the Department of Horticulture at the University of Arkansas. Curt has studied fruit physiology for 23 years. His areas of research include fruit crop management and crop nutrition, sustainable and organic production systems, and the development of organic methods of crop management. He teaches many courses, including courses in sustainable and organic horticulture, sustainability of managed systems, and stand-up comedy. He's going to be talking to us about the effects of ground cover management systems and nutrient sources in organic apple orchard. Curt?
Thanks a lot. Yeah, I'm between you and the break, so we'll get moving right along. I'd like to acknowledge the cooperators I have on this project. I represent a whole lot of people. We have an organic, sustainable team at the University of Arkansas. Several of these people are in the room, particularly my colleague, Dr. Johnson, who's our entomologist, my colleague, Dr. Garcia, who's our extension specialist and does the outreach in this project, my technical staff, Jason, who's in the back of the room, and Heather, who's listening on the webinar. Hi, Heather. Glad you're listening in. She's been texting me and sending me emails to let me know that she's really working today. We have a couple graduate students that work on this project. We have a number of undergraduate apprentices that are working in this project and 2 collaborating farms. So it's a wide group of people that I'm trying to represent this morning. Goal of our program is to develop sustainable and organic production systems for the South in our particular region. The project I'm reporting today is an OREI project on best management practices for establishing and managing an organic orchard in the southern region. Now, the southern region is a lot different than where we are up here. Of course, you know, this is the big fruit growing area right here. But if we get down to the southern region in this area under 36 degrees north latitude, approximately 7% of the fruit in the United States is grown there, the tree fruit. And so we have a great opportunity. But this is a very difficult region to grow in because we have a lot of particular kinds of issues. We have heavy mineralized soils, typically highly eroded, low nutrient content, very low pH in the hot, humid zone. We have a lot of insect pests, insects, a lot of disease kinds of pests. 2 that are limiting to us right now, plum curculio and a number of the summer rots for our organic system. We've got competitive vegetation. Out here, you know, you worry about 3 or 4 weeds. We're worried about 3 dozen weeds in 4 different seasons. So we're really talking, you know, hundreds of weed species or competitive vegetation species during the year. We also have kind of severe weather, very fluctuating winter temperatures, summer temperatures, flooding springs, dry summers. And to quote the great philosopher Frank Sinatra, our philosophy of organics is if you can make it here, you can make it anywhere. So we're really trying to push it out. We think that if you can do it in the South, maybe everybody else in the world will be doing a lot better at it. Our goal was to develop best management practices for an organic orchard. We're really looking at kind of technologies that are middle scale or scale neutral to help small farmers that typically have a local or regional sales basis. The project objectives here were to look at ground cover management options that organic growers could use, and also nutrition options, or nutrient source options growers could utilize for this. So our big questions that the growers posed to us when we started this project is how do we control competitive vegetation, excessive competitive vegetation in an orchard system, and then what do we use for a nutrient source, and what are the interactions between applying nutrients and trying to manage competitive vegetation. So we established an experiment that is an interaction experiment with 4 different ground cover treatments. And those ground cover treatments were using municipal green compost. All of our treatments we tried to base on local sourcing. And so we're using municipal green compost with the idea that we have an urban-based agriculture system. Wood chips, which just actually comes from excess wood chips that are picked up by utility companies. Shredded white paper, those are really final exams and term papers from the university that we're using. And then a mow and blow. In this case, the tree plot size that we're using, we're applying these ground covers in a 2 meter by 2 meter area. So that'd be a 2 meter wide strip of vegetation we're trying to manage. We're applying the mulches at a depth of 4 to 6 centimeters. We're applying them manually. Our nutrient sources were to do nothing. And so we're going to use the ground cover management system as a basis for nutrition and soil amendments. So the wood chips would provide soil amendments, the compost would provide soil amendments, or the mow and blow would provide all the soil amendments. So that gives us kind of one whole level that we have. Then we applied composted manure, which is poultry litter. We have a large poultry industry in our area. And then commercial organic fertilizer that we're purchasing, but it's also a poultry litter-based fertilizer. with also some alfalfa and other things in it. We're applying our nutrients at the traditional, conventional rates of application that are recommended for orchard establishment based on the amount of nitrogen should be applied per year, adjusted for foliar nutrient content. It's a factorial experiment, so it's a 4x3, 12 total treatments, 6 replications. The main effects were randomized in the complete block, and then we had split plot for the nutrient kinds of things. The cultivar was Enterprise. Our philosophy was to grow a disease-resistant, particularly a scab and cedar apple rust. Cedar apple rust is a limiting disease for us, probably more than anything else. So cedar apple rust and scab-resistant variety grown on M26. The idea was, again, to use a relatively vigorous rootstock to try to compete well, trained to vertical axis, managed by NOP standards. We started the experiment in 2005, planted the trees in 2006, so we're really looking at the first 5 years in the field for this particular report. Pre-plant, we leveled it. We added equine manure at 3 metric tons per hectare. We limed to adjust soil pH. We planted a permanent cover crop of fescue and white clover with a nurse crop of winter wheat. The trees were spaced 2 by 4 meters. Each plot consisted of 3 trees, using the center tree as the data tree and other trees as guard trees, completely guarded all the way around. The guard rows were planted on each side and at the end of all rows. So we are trying to isolate the individual treatment effects in this. So the key questions that I'm going to address today, and I'm not going to show a lot of data, but go right to kind of the summary general results that we have seen. How did we affect soil improvement and soil quality and health, including soil biology? I'm not going to discuss pest management, as my colleague Don Johnson will address that in other areas, and then a little bit on tree growth and productivity for that. So competitive vegetation, shredded paper controls vegetation wonderfully, followed by wood chips. Although we have a vegetation pest, Bermuda grass, that will grow right over wood chips by the end of the season can be a problem for us. Using municipal green compost actually stimulated vegetation, although it got through the composting process and was a certified composting process. We introduced a huge number of new weed species into our orchard by using this compost, indicating it probably had not been thoroughly composted. There was no significant effect of nutrient source on competitive vegetation. We had the same weed density, regardless of what we did for nutrition on that. When we used mow and blow, we had significant tree loss from competition during the establishment. We planted right into the vegetation, and then we're managing that by mowing in cultivation. We had significant tree loss because of that competition, but also something that I'd never experienced in my 20-something years at Arkansas. We had a lot of vole damage, and we've lost approximately 40% of the trees by creating great habitat with clover and fescue for voles. Now that's required us to trap those and remove those pests. Shredded paper also resulted in significant tree loss over the life of the experiment that we've had so far. This is possibly due to anaerobisis, which we're actually measuring. It actually forms this really nice paper mache over the top of it. That's using shredded white paper again. It also has some other issues that we're going to mention, and it created some sensitivities to winter injury that we experienced for that. In terms of the soil conditions, the ground cover affected soil temperatures. Shredded white paper resulted in cooler soil temperatures, and compost resulted in warmer temperatures. Our warmest soil temperatures exceeding ambient temperatures were in the mow and blow. So we were able to regulate that. Shredded white paper resulted in the highest seasonal soil moisture content, where mow and blow resulted in the lowest seasonal moisture content, required more irrigation. All of our treatments resulted in reduction in soil density. We started with very dense soil. They all tended to reduce that over the long time. Density in the mow and blow and the green compost was the lightest in the first 5 years. Shredded paper actually just slightly decreased soil density. They still were the heaviest soils that we have. In terms of soil chemistry, all of our treatments over the life so far have increased the soil pH. The shredded paper has increased the soil pH in excess of 8 now, and now we're having problems with alkaline soils, which are unheard of in our environment. So that's a real problem for that. The pH actually increased for the first 4 years and has been stabilized for the last several years after that. That increase in the pH in shredded paper is due to the amount of sodium that white paper has as a light stabilizing agent, and now we're having a problem with real high levels of sodium in our soils, which that's what we're fighting off for that. Nutrient source had no effect on pH, although the poultry litter seemed to have a slightly lower pH than anything else that we used. Green compost and shredded paper both increased electrical conductivity and the salt content of the soil compared to wood chips in our mow and blow system. In terms of nitrogen, the green compost that we added as a means, not as a soil amendment, but a means of controlling competitive vegetation, actually resulted in a 3 to 5 times increase in the amount of nitrogen we would normally apply to a system. So we're really over fertilizing these quite a bit. In terms of nitrogen use and nitrogen loss for this, we have very low nitrogen use efficiency in the green compost system. In fact, it's down around 4 or 5%, which means we can't account for huge percentages of the nitrogen under our compost system. Wood chips had the same kind of recovery rate, but our nitrogen use efficiency went way up with that. Shredded paper and mow and blow had very low nitrogen, very high nitrogen use efficiency, but our nitrogen was in the lower level and probably not sufficient for where we needed to be for that. This one piece of data that I have that I'll show you kind of demonstrates the range of nitrogen we have. Up here with the green compost, we're applying close to 1,000 grams per tree per year of nitrogen. And this line represents the cumulative yield over the first several years, the early production years, and it's a typical mineral by yield kind of curve that you can see that we're over applying nitrogen. We're growing very large, vigorous trees, but non-productive trees at that. The green compost had a lot of late season nitrogen release. In fact, more than we could account for in our nitrogen balance for that, which is interesting. Green compost had very high extractable nitrogen. We're using these PRS membrane probes to follow that. Wood chips consistently had higher available and total phosphorus in the soil, which our soils are not typically deficient in phosphorus, but it's typically tied up because of our pH, which is important to us. Poultry litter and commercial fertilizer increased nitrogen phosphate, but not significant in all the years that we had. Poultry litter had the highest extractable and soil available nitrate in the spring during sampling and the time that would be available to the roots compared to the other nutrient source treatments that we had. We're interested in carbon sequestration in the organic system, and so been tracking that from the life of this experiment. And what we see is that the soil organic carbon has increased threefold from the time we started it through the first 6 seasons. So we're actually starting to sequester carbon inside of the root zone just by our treatments. The greatest treatment for this was the green compost, and that we had a lot of carbon sequestration for that. The wood chips, although not statistically different, increased carbon sequestration by 2-fold compared to the other 2 treatments for that. There was a significant correlation to the carbon and nitrogen that we see in the soil that's being applied. In terms of the microbial biology that we see for this, microbial biomass has increased 2 to 4 times from the beginning of the experiment through the first 6 growing seasons. What we see with that is it actually increased dramatically in the first 4 seasons and is starting to stabilize. In our initial data for this year shows that's true. So it took us about 4 or 5 years to come to homeostasis in the biology for this. The greatest increase in the biomass was with wood chips and shredded paper. The most seasonal variation that we're seeing is with green compost, where it'll spike early in the season and then crash later in the season. Dissolved organic carbon increased in all treatments except mow and blow, had our greatest increase with the green compost and the wood chips. So it was 6-fold increase with the green compost. Soil aerobic activity also increased, and it's proportional to the soil biology and soil biomass that we had measured for that. We saw increases in soil respiration rates as an indicator of biology for both the green compost and shredded paper. In terms of the kind of macrofauna that we're measuring, we're not doing kind of things like Professor Bird is with the microfauna, but we saw the diploids and Haplotoxidia both increased. Earthworms increased with green compost and wood chips is a good indicator for that. We see Ossipodia have increased in the shredded paper and wood chips. That shredded paper probably again indicating this wet condition and possible anaerobisis. Negligible observations of differences in the mow and blow treatment. So no real increase in mow and blow with the kind of macrofauna that we would like to see. In terms of tree nutrition, early season nutrition for nitrogen was significantly increased by the wood chips and the green compost, but all of them were kind of similar by the time we get to late in the season. After 6 seasons of watching this, the ground cover nutrient treatments all had adequate tree nutrients and all of our nutrients, so we're able to know that at least by our existing standards, we're able to satisfy those kind of needs. In terms of tree growth, the wood chips and the green compost resulted in the largest trees. All of the trees kind of achieved the top wire, 3.25 meters that we were trying to achieve by year 3, but our largest tree trunk diameters and cross-sectional area would be with the green compost followed by the wood chips. Shredded paper had the smallest tree size, also has smaller leaves, less chlorophyll, lower photosynthesis, and a less dense tree canopy. After 5 growing seasons, all the ground cover treatments, all the nutrient treatments had adequate similar foliar nutrients, and we're not seeing any big treatment differences as a result of that. In terms of early yields, wood chips and green compost had the highest yield, mow and blow had the lowest yield, as followed by shredded paper. There was really no difference between commercial fertilizer and poultry litter as a nutrient source, but both those had more nutrients than the no fertilizer treatment. There was no effect on fruit size or quality for that. The green compost plus additional nitrogen treatments, as you saw in that early graph, provided too much nitrogen. We grew big trees, although the yields were following that. So our summary conclusions: shredded paper and wood chips provided our sufficient competitive vegetation that allowed good tree growth. Green compost provided excess nutrition. The way we're using it as a ground cover, not necessarily as a soil amendment. Green compost resulted in significant improvements in soil biology, quality, and health, and shows some real promise in that. Wood chips probably provided, in our situation, the best combination of nutrition, soil biology, soil quality, health, tree growth, and cropping. At least at the way we were applying these treatments. Either nutrient source provided sufficient nutrition, and not applying nutrition, obviously, as a control resulted in reduced growth and cropping. Mow and blow resulted in the greatest tree loss, smallest trees, and lowest cropping that we had. No nutrition resulted in adequate tree growth. The trees are actually adequate size, although on the small size, but the cropping has been minimized with that.